All right, last video to finish up trapezoidal sums. I have a scientist who's measuring the depth of a river, and I know the distance across the river, I kind of sketched it here, is 24 feet. I'm trying to ask me here to approximate the area, like of a cross section of this river. So if you can imagine looking, you could stop the river and cut through it. Right here at the shore, the first shore, the water is 0 feet deep at the shore. By the time I get down to 8 feet across, the depth is 7 feet. If I get down 14 feet across the river, it gets down to 8 feet deep. I'm almost at the other edge, so 22 feet across, the depth is 2 feet. And then at the other shore, I have a depth of 0 feet again. So this is kind of like you can imagine flipping this up so that you could think about the rectangles, but really I'm just trying to find the area of this cross section of water. So I could imagine, I'm going to use trapezoidal sum, which means for my rectangles, not my rectangles, my trapezoids. So I'm going to average that height of 0 and that height of 8. Notice that when one of your heights of your trapezoid is 0, then you end up having a section that looks like a triangle. This is going to be my next trapezoid. I'm going to average the 7 and the 8. Here I'm going to average the 8 and the 2. Here I'm going to average the 2 and the 0. I'm going to have another triangle at the end. So I'm going to do width times the average of the heights. That's going to be a width of 8 because of the difference between 0 and 8. Times 7 plus 0 over 2. Plus the next width is the difference between 8 and 14. That's 6 times the average of the heights. So 7 plus 8 over 2. Plus the next width is the difference between 14 and 22, which is 8. Times the average of 8 and 2, so 8 plus 2 over 2. Plus this distance, the difference between 24 and 2 is 2 times the average of 2 and 0. You could leave that answer. That would probably get full credit. Actually, no, the second part of this problem is we're going to need to simplify that answer, and we're going to need to give units. So my units, every time I multiplied a width, which was measured in feet, times the average of 2 more depths, so a distance and a depth, both measured in feet. So I'm going to have feet times feet, feet squared. Final units is going to be feet squared. I'll let you perform your own calculation. That turns out to be 115 feet squared. All right. So we talked about how to think about errors that you might have when you use rectangles to approximate area. We're going to talk about errors that we know about when you use trapezoids to approximate your area. Okay, and to be totally frank, I'm going to have you write this in your notes. Do I remember this by heart, these words that I'm going to have you write? I don't actually. I remember that the error introduced by making a trapezoidal approximation depends on whether your function that you're approximating the area under is concave up or concave down. So I usually draw a little, whoops, change the pen, little concave down, like a upside down parabola, and I imagine trying to draw in a trapezoid underneath it. So let's say I want to go from here to here, and it's pretty easy for me to see that if I tried to fit a trapezoid in this upside down parabola, it's going to be an underestimate because I'm going to have this leftover area here. So specifically a trapezoidal approximation of the area under the graph of f over the interval a to b is an underestimate if f is concave down, which means if I had a concave up piece and I tried to draw in a trapezoid, There's my trapezoid. All this extra stuff is not area under the curve, but I'm going to include it in my trapezoid. It's going to make it an overestimate if my function that I was trying to find the area under is concave up. So overestimate if that function f of x is concave up. So now I'm going to use this problem to practice. So if I have the curve y equals x cubed, I want to approximate the area under y equals x cubed from 0 to 6. I'm going to use 3 trapezoids. And then I'm going to say at the end whether my answer is an overestimate or an underestimate. I'm going to switch to a bigger screen. All right, so for the function y equals x cubed, I've been asked to find the area under the curve between 0 and 6. I'm going to use 3 trapezoids, which means each trapezoid is going to have to be 2 spaces wide. I'm just going to make a little table of values. 0 cubed is 0, 2 cubed is 8, 4 cubed is 64, 6 cubed is 216. Let's try drawing those in. This first trapezoid has one height that's 0, so that's going to end up looking like a triangle. My next trapezoid, I'm going to end up averaging the heights at x equals 2 and x equals 4. I'm just going to average 8 and 64. Between 4 and 6. All right. So I'm going to add up the areas of those 3 trapezoids. Each one of my trapezoids happens to have a width that is the same. So I kind of set myself up so I have 3 trapezoids here. I fill in the width for all 3 happen to be a width of 2, and I'm going to fill in the heights. So this is going to be the average of 0 and 8. This is going to be the average of 8 and 64. This last trapezoid, I'm going to average my 2 heights. My 2 heights are 64 and 216. 64 plus 216. So now I'm gonna simplify this however I can. I'm going to happen to cancel those 2s, and that 2, and that 2, and that 2. So this is going to be 8 plus 8 plus 64 plus 64 plus 216. I'm going to simplify that the best way I can. That's 220, 280, 340, 344, 352, 360. So my approximation is going to be 360. I didn't have a scenario here, so I don't have units to specify. But the last part I've been asked to state is this approximation of 360 an overestimate or an underestimate of the actual area under that curve? So I'm going to answer by saying uh, 360 is an my function y equals x cubed at that part of the graph is concave up. If it were the case that the concavity changed somewhere, I wouldn't be able to make this statement that I'm about to make. But since the concavity is the same for that whole interval 0 to 6 that I was thinking about, I know that concave up, underneath, so 360 is an overestimate because y equals x cubed. Oh, not easy to make a cube here. Is concave up. on the interval zero to 6. That should both be closed parentheses. Doesn't actually matter if they're both open or both closed. There we go. 0, 6. 6. Final answer. My 360 is an overestimate because that function that I was trying to find the area under is concave up on that interval.